Hi, in today's episode I'm going to show you what changed in the Powerwall, and then we have to make an upgrade to the controller. Let me take you to the Powerwall and I show you what happened. Alright, we arrived at the Powerwall and I want to show you what I changed. So in the last days I received some items again, so I could finish the DC breakers. We have now the main breaker for the battery and all other breakers for the devices. And then I have changed the position now from the shunt of the coolant meter. So before it was on the discharge, but now it's on the battery side, so we can actually see charge and discharge, so both ways. The meter is now reset to 0. We are empty on the battery and it will go now up and down as we charge and discharge. Then here I added the 12 volt bus bar. We have several 12 volt devices now, which is the DC shunt, and what I made new is a bank of fans. This is 4 12 centimeter PC fans, and they are cooling down all the equipment here. Here you might have seen something, and this is the topic of today's episode as well. This is a 50 ohms 50 watt resistor, and what this is for I will explain you now. So at the Powerwall you just saw a resistor right next to the DC contactor. And what is that for? You know, we are switching the DC side of the inverter. This is actually the natural way how this inverter works on daily basis. All that inverter is still a solar inverter. It has a built-in MPPT controller and would usually be operated on a solar array. When it's powered by a solar array, you know, the buildup of the voltage and current is very slow in the morning, and then it will disappear at the evening. But why I have that inverter is because it can also operate just on a battery. If it is powered on a battery, there is no slow power buildup anywhere, right? The battery is a massive power source. That battery can provide 500 amps if you need it for some time. You have probably heard of a phenomenon called Inrush current. When we switch off that inverter, the DC side will completely deplete of energy. And you know that DC side of inverters, there's one component built in which is very important because it is smoothing out the power inside of that component, and it is called a capacitor. And usually DC side capacitors are pretty big, so they can hold a lot of energy. And the thing with capacitors is, if they sit at 0 voltage and you energize them, they initially don't have resistance. So the resistance of a capacitor will rise while the voltage is rising. And this is causing, if you just flip now the switch to on, this will cause an initial current spike, which is called the inrush current. So what we want to build in the Powerwall now is a kind of soft start mode. So there will be now an extra relay in the DC cycle, which will activate the bypass over the resistor. That's why we need to upgrade the controller. I only have 4 relays built in there and they are all occupied. So we will build in extra at least 1 relay, and that relay will be used to energize the bypass first, and after, let's say, 1 to 2 seconds, when there was enough energy put into the capacitors already that the voltage started to rise. This is nothing different than a pull-up resistor. Okay? So when the voltage is already rising after maybe 1 or 2 seconds, then we will just close the contactor. So it is a two-step switching when you energize the inverter. First bypass, and when the bypass energized, then contactor. Yeah, so that is a very important part. It is extending the life of many components, not just the inverter. It will extend the life of the BMS, maybe figures, right? But most important is that the inverter is protected and the capacitors stay healthy for a long time. Okay, so that was the theory behind today's episode. I will pick up the stuff for upgrading the controller. So before we are going to finally install the controller into the electronics cabinet, I want to make 2 final last-minute upgrades. One upgrade is another relay module, this time with 2. We only need 1 for the time, so 1 we will keep for spare. And the relays, as you saw at the electronics cabinet, for our capacitor pre-charge system, the so-called soft start for the inverter. And the second module I want to install is a SD card writer and reader. So with this SD module we can store some data from the Powerwall for later analysis. Now you could of course say, yeah, why don't you use ESP8266, connect to the Wi-Fi, send the data to a database, analyze it with some kind of program? Yes, we could do that. Maybe somebody of you will do it, but for me, I just don't have a reason to do it. Maybe I want to look about data for 1 day or something like that, but I don't need it every day. So for me, it will only be locally stored, the data, and that's it. We can take out the SD card, put it on the computer, and just go. So, if you look into our box, we have a nice space here available for the second relay module above the other one here. The only thing we need is spacers, and put it there, and then use jumper cables to our Arduino maker. And for the SD card module, I want to put it somewhere so that I can actually cut the slot somewhere into the case, and we can insert the card from the outside. So don't need to open the case for that. Let's see what will be the best place. I don't know it yet, but initially we have to take out everything again and drill the holes for the new modules. Okay, I will do that now, and then we'll see again how they turned out. Hey, what did I do? Okay, the second relay module and the SD card reader. I took out one of these rubber gaskets here and cut a little piece out of the case, put it there with hot glue. There was no other way to put it, and yeah. So now it's here, all is connected to the Mega. I'm gonna close this now, try to write some code for the SD card reader, Tomorrow we are going to install this into the electronics compartment. Okay, good morning guys, it is the next day. The controller is done. I have completed the coding to implement the SD card reader. It is all working. The only thing missing is still my new rotary encoder, but I don't care about it anymore. The Powerwall is prepared. What I want to do is install this, and then I want to run the Powerwall already on the controller. Let's take it, bring it to the Powerwall and continue. Okay, for the day's work we don't need too much. I just brought the screwdriver, some cables, and then we will put the controller on its place. And what we need to connect is one charger, the contactors, the resistor, the fans, and then we want to know the voltage of the back, of course, so voltage sensing, and our Modbus, of course. Yeah. Let's get what we need, and I will start with the installation and show you from time to time how the progress is going on. Right, okay, the first part is finished. So this time I only connected low voltage devices, so the 12 volt stuff. I connected 3 of the relays. So the most on the down, that is the fans. The next on the up is the contactor, and the most on the top, that one is the pre-charging. So this goes here, and you see that is the bypass resistor. And then I connected here the black and red wire. This is the voltage from the battery, and here the 2 wires for the Modbus. Another one, 12 volts for the LED lights. The controller will already work. I will close the lid, and then we can see some values on the display already. But just for very quickly, so here plus voltage sensing and minus. So the voltage is taken straight from the last terminals of the battery, so then there is no errors, measuring errors from like wire voltage losses and stuff like that. Okay, so I'm closing the controller lid, and then we will check how it works. Okay, I switched the controller on now, and we actually have a battery voltage indication. 53.47 here, 52.906. Probably we have to calibrate it a little bit. The state of charge, just forget it for the time. We press this on the second page, we see some power and temperature, but the fans are not running, so yeah, I have to check what's going on here. It doesn't do like it did before now in real life, so I will come with the paper and then write down all these bugs and try to figure out what is wrong. But otherwise it's okay. I will next connect the charger and then see if we can maybe today already run automated charge and discharge. Okay, I see you again in a bit. Okay, I've now also connected the AC charger to the controller, so now I can actually control everything by the box. The automatic modes, they are a little bit messed up yet, but there's manual modes, so I can choose this manually. The third mode is not changing, so probably there's some jumpers somewhere fell off. I don't know, we have to check that one. But here in mode number 5 is only the charger 1. Charger 1 is not here, but charger 2, here I can just activate it by the box now. The inverter as well, the soft start is working. 2-step switching is perfectly working. So the first step over the resistor, and then in the second step is switching the contactor. And there's no more like big clicking or something like that. It's very nice. So the Inrush is totally gone. Right, so I will go to the computer and change some code and try to figure out a few bugs, and then maybe overnight it will work already much better. So I think that was it for today. Thank you for watching today. I hope you're still interested in my project, and I will talk to you again next time. Bye bye.